So earlier this year in February, the Vostok expedition, the Russian expedition, was in Antarctica trying to actually drill 2 miles down into the Antarctic ice, penetrate this lake below the Vostok station. And it was the world of explorers and scientists were gripped. And I'll tell you why, because it was a high-risk expedition. And I wanted to just show you a shot of, this was the Explorers Club on Saturday night. And I just wanted to mention that because we've all been, I've been an explorer for about 5 years. And when I joined the Explorers Club, I never dreamed that I would be diving into an oil slick. In fact, in my whole life, I never dreamed I would do such a thing, but I got involved with the Gulf of Mexico, and we have been looking at the high-risk activity in the world, from drilling, from trying to access fuel. And when the Vostok expedition started, they've been drilling for about 20 years. This is their station in East Antarctica, and the Antarctic ice cap contains about 90% of the world's ice and 70% of the world's fresh water. The biggest lake in the whole ice cap is Lake Vostok. So their desire to be the first to penetrate this lake led them to start the drilling years ago, and it was so risky that international concern emerged, and they were forced to stop about 8 years ago and sign an Antarctic treaty that controlled some of the ways they were doing this. So they've been drilling for all these years in this frozen wilderness. This ice cap has 29 million cubic kilometers of ice. This is Lake Vostok, which lies beneath from satellite. It's been buried for 20 million years. This is the largest of the 140 Antarctic freshwater lakes. It's believed to contain unique life forms such as extremophile bacteria. So here's the size of Lake Ontario, and it has a similar footprint. You can see it's a surface area of about 7,300 square miles, with a volume of 16,640 cubic kilometers. And Vostok is actually about the same surface area, 6,000 square miles, but with three times larger volume, and that's because of its depth. This is the drilling expedition. You can see the station on top there, and going down 2.3 miles to reach the surface of this lake. At the same time, it's the end of the austral summer in Antarctica. It's the coldest place on the Earth, and the temperatures were dropping so rapidly that they had to get out within only a few days. They had a very small window of time. The implications of this expedition are just tremendous, particularly for astrobiology, the quest for life beyond Earth. The question is, do other ice-encrusted planets contain vast reservoirs of water at the core? And does that water also have the potential to contain microbes, which could represent life as it formed 20 million years ago, millions of years ago? So we're looking in astrobiology. The big interest is the Saturn moon Enceladus, which is ice-encrusted, and the Jupiter moon of the Galilean family, Europa. The scenario that's been posed is that you see the crust on the top, and you have the very cold ice graduating into warmer ice sitting on top of water. And this is believed to be seawater, ocean water actually, that's warmed by core heat. So the Russians have been going at this for some time. They're using 50-year-old drilling equipment. This is a great international concern because it's the largest of this freshwater on the planet, and we, some of the things that could go wrong, they were using toxic drilling fluids, freon and kerosene to keep the drill warm enough going down versus other countries using a melt drill with heat, hot water, and there's no containment measures whatsoever on this site. And so biggest risk of all would be that there would be an explosion, like a geyser, of the gas-laden water. The gases are very concentrated in that water. It's dissolved oxygen and nitrogen. So there would be enough water to send a huge amount of vapor to the atmosphere of Antarctica, change Antarctica's weather, and radically alter ocean chemistry. They did reach the lake. We were told, at any rate, it was reported in the international press that they penetrated the the crust, reached the water, took out a barrel of water, and left. Temperature was dropping to minus 80 degrees centigrade at the time, and it's just impossible for anyone to survive that. So what we were concerned about is that the oceans are at a tipping point, we believe, from cumulative stresses already. The stresses are multifactorial, but primarily from pollution, toxic pollution, climate change that's driven by excessive carbon dioxide in the atmosphere, and overexploitation, meaning overfishing and other things, mining, strip mining, the bottom of the sea, trawling, and so forth. In 2009, I chaired an Explorers Ocean Forum and at the club, and some of our top ocean scientists, including Sylvia Earle and David Gallo, who's a robotics pioneer from Woods Hole, Nancy Knowlton, who's a coral reef expert from Smithsonian, David Guggenheim, and myself. We got into this very deeply and became aware that there's a number of concerns. I mentioned some of those, and there's widespread public ignorance about the extent of the crisis that we're actually in with our oceans. So we called for action. We said we have less than 10 years to change human behavior and get the word out and have industry, innovation, changes there, and certainly changes in policy and legislation. But as of 2011, an international coalition of marine scientists made a report now to the United Nations saying that the degradation of the oceans is happening at a much faster rate than was predicted. Our predictions were off. These cumulative effects are causing the ocean to go into crisis, and it's a faster process. We are facing a global mass extinction of marine species within a single generation. And so what are the trends? What are we looking at today? We've been looking at these trends for some time, but the problem is they're worsening. I want to talk about carbon dioxide, which is causing the oceans to become warmer and more acidic. Since the beginning of the Industrial Revolution, we've added about 500 billion metric tons of carbon dioxide to the oceans, and you can see there's an in tandem rise of atmospheric carbon dioxide and temperature, sea surface temperature. And with the warming, we're seeing cataclysmic trends. The melting of the polar ice is accelerating at both poles. Sea level rise is already occurring, predicting to get worse. We've seen sea ice decline 30% in the past 20 years, and this is a trend that's accelerating. We are predicting that Earth could warm 3 to 4 degrees centigrade by the end of the century. For some species, predator species like polar bears, they are living at the edge of their physiological tolerance range already. From pollution and starvation, they are unable to actually, with the melting of the ice, get to their food. We've disrupted their entire feeding cycle, and we've also, they are carrying loads of pollution. So it may be the end game for polar bears during some of our lifetimes. The population is very low and endangered. It's dropping, estimated to decline by another 2/3 by 2050. And as it is now, the population is not sustainable. Carbon dioxide has made the oceans 30% more acidic than they were 200 years ago. And in acid oceans, the skeleton of calcium-forming organisms just simply dissolve. This is shellfish, corals, also larval fish cannot survive. And it's like an osteoporosis now of the oceans, happening in every ocean. We're looking at possible extinction of corals. We've lost worldwide 25% in the past 35 years, 70% lost in the Caribbean, and 50% in the Pacific Ocean. These are the nurseries for 25% of all marine species, so it's a major concern. And when we look at pollution trends, there are also some things that are honestly getting worse very quickly. The coastal dead zones, the plastics, microplastics, and the death of animals. And we're all tracking this. There are over 500 dead zones on coastal areas worldwide. Some of the worst are in the Baltic, the Gulf of Mexico. And it constitutes an area of 246,000 square kilometers, or roughly the size of New Zealand, that is oxygen starved. These are anoxic or hypoxic areas. They either have no oxygen whatsoever or they are oxygen deficient. And then the severe eutrophic areas are also increasing. There are about 240 of those. So these areas are heavily impacted on the coastlines from fertilizer runoff and sewage. And, I wanted to mention the Chesapeake, where you have all those chicken farms right up on the edge of the water. That's causing massive amounts of eutrophic water. So what happens in this environment is our fish start to become more and more toxic. We're seeing more fish kills. This is 1 million menhaden in Narragansett Bay, and we are beginning to worry more about, are fish safe to eat? Are they simply becoming so loaded with chemicals that we should be avoiding certain kinds of fish? And I will talk a little bit more about that shortly, but the plastic pollution problem is growing. There is plastic rubbish in huge ocean gyres that is the size of small continents in every ocean of the world. This is the Great Pacific Garbage Patch, and what happens in these gyres, the currents are very slow compared to the rest of the current flow in the oceans, and it's just simply going around. Once the plastic builds up in there, it can't get out. Problem is that plastics degrade quickly. By photolysis in seawater, and break down to very small pieces and microplastics, which can last for 100 years. They adsorb to and release toxic materials in the water, persistent organics, and they are ingested by seabirds, marine mammals, and cause hundreds of thousands of deaths every year. And they are also, as you're more familiar with, strangulation by these plastics. But here we see a beach in Hawaii where plastics have broken down to small pieces, bits all over the place. It just looks like when you want to pick up a bunch of shells, you get plastics. We're seeing more and more of this all over worldwide. But the worst of this is the microplastics we're now discovering in the sand itself. These are less than 1 millimeters in size, and they're tiny fabrics, they're fibers. They are coming from washing clothes containing polyester and acrylic fiber, and there's contamination on the shorelines of 6 continents now by these microplastics. These are definitely getting into the cells and the bodies of small animals and being ingested by bigger animals, so they're moving up the food web. We're going to see that plastic in the DNA of the animals now in the ocean. They contain, plastics release organic chemicals, as I said. They also contain these plastic monomers and additives, plasticizers, that are like, you know, some of the brominated compounds I'll talk about, but they are highly toxic. So this we see commonly is animals that get strangled, and then more and more the birds, the turtles, are ingesting the plastic thinking this is their food, and then they, you know, they also feed this to their young. And I've been working very much on sentinel species, the species that are signaling contamination of marine ecosystems, and primarily the predator species, marine mammals and large fish. And we've been doing a study now along the Northwest Atlantic from Canada down to New York, or just below New York, and it's the first time a big region-wide investigation has been done, so we published a lot of papers on this. We also looked at the fish that the animals are eating, and some of those fish are herring, hake, haddock, flounder, and plaice, American plaice, the right-handed flounder, and I'm sure these are fish that are very familiar to us. They're actually commercially imported fish stocks, which are the primary diet for we are studying harbor seals. So what we do is we respond to stranded animals, and this is the CSI part of the work. We take tissue, we investigate, in this is forensics, we investigate the chemical contaminants in the tissue. And what we found is that marine mammals contain such high levels of hundreds and hundreds of compounds that are toxic and bioaccumulative and persistent, that they are considered hazardous waste on our beaches. And these animals, for example, PCBs, the level to be considered hazardous waste is 50 parts per million in fat. That's on a lipid weight basis. 50 PCBs, parts per million. These animals contain 80 to 100 parts per million, and this is what we routinely find. That's for one compound. There are hundreds and hundreds of other compounds. So as in the course of doing this research, I got very curious. I had my own blood analyzed, and I discovered that I have 113 different chemicals in my body, and including the PCBs, DDTs that were banned in the 1970s, but are still very persistent in recycling through marine food webs. Also, a lot of pesticides. The PBDEs are the flame retardants, and the last group are the perfluorinated compounds. One of the trends is that marine mammals are dying off, and the die-offs are increasing in frequency, and it started in the late 1980s when I started studying contaminant loads in marine mammals. And so you can see on this slide there's die-offs of animals all over the world, every ocean of the world. This is because they're the marine top predators. They're feeding at the top of a contaminated food web, and they're containing levels of compounds thousands of times higher than any other animal on the planet today. They're thousands of times higher than the levels in human beings, so they are sentinels for this long-term effect. And we're not postulating that they are dying because they contain 100 parts per million of PCBs that suppress their immune systems and their reproductive systems and cause brain damage and cause all kinds of hormone alterations. we're not saying that. We're saying all this whole chemical loading is weakening the animals. So something comes along, more warm weather, storms, probably more likely a virus, a bacteria, an infection, and then they're so weakened they don't have the resilience. I say they're not normal animals anymore. And this is a very sad thing to realize. Our marine mammals, seals, dolphins, whales, they're just simply not normal. That's why we're seeing more and more of these die-offs. So just this fall, this spring rather, we've had this fairly large die-off of dolphins around Cape Cod. 200 animals have died, all in the same space of time. The die-offs in the Gulf of Mexico are going on. There are 600 animals have died, very much related to the oil, and there are die-offs all over the place. They just keep coming, keep coming, keep coming, and I think it's a sign that our oceans are becoming more toxic. So as you saw in the video, I got involved in the Deepwater Horizon oil spill, which happened on Earth Day, April 20th, 2010, and which has led to the exposure of people and wildlife to oil and the compounds, the toxic compounds in the oil. Until the well was capped in September, we saw nearly 200 million gallons of oil going all over the Gulf, and 2 million gallons of dispersant were applied. As a marine toxicologist studying the impacts of chemicals on the ocean environment for many, many years, I was asked to go down to the Gulf to investigate what was going on with the dispersants, because there was a lot of controversy about the decision to use chemical dispersants. So I got there in late May. The oil was very thick in the water, you can see. And here you see a satellite image that same day. The slick is approaching Mississippi Delta. This was called Ground Zero, the Grand Isle of Louisiana, and oil's getting into the beaches and into the lagoons. So we went out 40 miles to this rig where oil had been dispersed earlier that morning, and we put on a lot of protection as much as we did not have hazmat gear. We should have, but we were covered and went down in the oil. So this is footage taken by the Cousteaus the next day, and they did have hazmat gear. But as I went in the oil, what you see here is the oil being broken up into tiny pieces by the dispersants, and as you go lower, it gets smaller and smaller. Now what's happening is that it's releasing tons and tons of hydrocarbons, the polycyclic aromatic hydrocarbons, that are, some of which are carcinogenic and mutagenic. And the further I got in this underwater voyage of mine, I started being surrounded by more and more dead things. And so that this whole mixture of oil with dispersant, it's releasing hydrocarbon and solvent into the water that's very, very concentrated. And in addition to that, it's taking the oil into the body. So as soon as I was, you know, when you go diving and you go in the water, there's some other dead stuff, but I was just really literally surrounded by dead bodies down there. That was what was horrifying to me. When you go diving in the sea, you see the pretty things, you see the beauty of it, and it makes you feel good. This was the exact opposite experience. It was just horrifying. I was watching death, a cloud of death in the water. So I came to the conclusion that I should get out pretty quickly, and I did. And I got a very sore throat from being there and inhaling the solvents, particularly at the surface, and I also got a bad headache, and my colleague did also. But we were lucky. Some of the divers got really sick who were in for longer. So what's happened here is we were at this decision point of deciding to apply all this dispersant, and why. We applied 2 million gallons by mid-July. We injected it at the wellhead That was the first time that's ever happened at a mile deep. It was called by some people a chemical experiment. The consequences of this were not known. But using chemical dispersants in an oil spill is a cheap and dirty way to sink the oil, get it out of sight. And one of the drivers on this was BP was getting fined for all the oil that was captured. So they were very eager to use dispersants, and our government went along with it. The other thing that happened is BP, the Corexits that were used were BP products. The company, Nalco, is owned by BP. They had stockpiled a whole lot of it, and this had been since the Exxon Valdez spill, although we knew some of the effects of the more toxic version. There were two types of Corexit. One was 9527, which is known to cause internal bleeding. Well, they used it anyway until they ran out of it. Then they switched over to the more, they said, less toxic, 9500. But both of those products contain solvents, and like benzene, and some of those are very, very toxic. So what we discovered was that not only are the dispersants breaking down the oil, they also break down the lipid membrane cells and organs, so the oil can get into the body more readily, and then they target the same organs and they damage the same organs. I was appointed to this Strategic Sciences Working Group. This was a Department of the Interior appointment, and we were charged with assessing the whole incident and carefully going across all the sectors: wildlife, environmental damage, human health, even damage to communities, socioeconomic problems, cultural damage. And we then delivered our policy advice to the agencies. I predicted that the corals would be hit, and they were, because the dispersants took the oil down to the very deep part of the ocean. Down in the deep cold water, the microbe theory, the microbes are going to eat up the oil. Well, they don't work very well down there. They're very not functional. Corals are very, very sensitive to this mixture. When they are exposed to the mixture, they cannot fertilize themselves. When they're exposed to oil alone, they have almost 100% fertilization. I also predicted that the dolphins would be severely impacted because those animals are breathing through the blowhole coming up to the surface, and with the plumes that are now moving around in the water column, there's no way they could come through this massive hydrocarbon without taking it into the lungs. And when it gets into the lungs, it causes chemical pneumonia. And you saw there were some people that suffered from that in the Gulf. We predicted human health impacts would be caused from, the direct impact of chronic exposure. We said there's no safe level of exposure to the oil. And this was a very upsetting message to the agencies, because at the time, a lot of people in the government were trying to minimize the negative PR about the oil spill. And this was, one of the problems, because BP was trying to minimize the negative impacts and do some very kind of amazing PR for themselves, which they are still in the process of doing, but our government also acquiesced in that. So we were worried about the chronic impacts, particularly on these rescue workers. This is the most idiotic way to pick up oil that is imaginable to the human brain. That is to send shrimp boats out to gather the oil with these booms and bring it into the boat, throw absorbent material onto it, gather it up yourself, put it in these big plastic bags on the boat. The exposure was off the planet for these people, and so many of them got severely ill. They're highly exposed to all the compounds. They're covered in oil by the end of each day. And that's not the worst part of this. They were told not to wear respirators. And some of them said, well, they were not given respirators, and they were told not to wear. Some of them went out and bought their own respirators, and were met by the BP boats the next day, said, take the respirators off. If you're wearing a respirator, you're not working for us. It makes it look bad. You know, there was a lot of media coverage of this event. So here's what, this is a slide from Exxon. Here's what a person should be wearing: the respirator, the hazmat gear, the whole thing, when handling these materials. And what is missing? Everything. So many people were out there trying to help with this very, very unintelligent collection of oil. And you know, so we have high chronic exposure, chronic health effects. We have thousands of people sick. We have litigation. We have class action lawsuits, individual lawsuits. We have lawsuits now for litigation for environmental damage. And the whole story is not over with. I just want to say that we have a lot to learn, and we are learning a little too slowly. The President's Commission on the Oil Spill delivered a telephone-sized book of recommendations. Not one of those recommendations has been followed. There's not been one piece of legislation passed in Congress to make deep water oil drilling safer, and we have all these people sick. And on top of that, I find it so arrogant that we are entertained now on television by a BP multi-million-dollar advertising campaign saying everything's fine down there. And I can guarantee you the scientists do not think it's fine. The people who, all of us who were working down there, would not agree with that. It's just an impossible message. And it's a very unfortunate message, because we deserve more from our government leaders, and we deserve more from our industry leaders. But what's happening, it is not happening, and this is the largest environmental disaster in our history. We're trying to whitewash it now on television. We need to learn from it. We need to go forward and do a better job. That's just not happening now. So I was there a year later and went on, this is some of our sites we have in the Gulf, and we drilled down about 6 inches in the sand. This is on Grand Isle, and oil is still bubbling up, and it's going to be decades before we know the full extent of the damage in the Gulf. But this is actually liquid black oil. It's not tar balls, it's oil. The oil is right there in the system. It's continuing to wash on shore, you know, and people are getting exposed still. So what have we learned? Not really that much. We are rushing now to drill. There's drilling going on off Cuba, deep water, and this is, the company is a Spanish company called Repsol, has a very bad environmental record in other parts of the world. They have a rig that can go down 12,000 feet. The Deepwater Horizon rigs exploded at 5,000 feet, 1 mile. This one's just a mammoth thing. And the other, you can see the other rigs there, they are proposed leases. They are leases that are going to be passed, given. And this one's already in gear. And it's 45 miles south of the Florida Keys. It's just south of a loop current, which will take, any material would be taken right up to the, eastern side of Florida, up the Atlantic. So there's a lot of concern now in Florida about this drilling that's starting. And we're also looking at drilling in the Arctic. Looks like we are going to allow drilling in the wildlife refuge of the Arctic. There's already some oil there, but we're going after this oil very, very, with full steam, and really with no assurance that we're any safer than we were before the Deepwater Horizon explosion. So as oil is transported around, we also have the hazards related to shipping. This is the Concordia wreck, Costa Concordia off Tuscany, carrying 2,200 tons of oil and diesel on board, and they were able to thankfully get this oil off before this massive ship broke up. This is a 950-foot cruise ship, and we were just lucky that the weather permitted the oil to be taken off. It's very difficult to get oil off. There was a wreck off of New Zealand very recently, and this ship it's a container ship carrying 1,800 tons of oil. This is in October. The Rena wrecked off the very pristine area of New Zealand and leaked 300 tons of heavy fuel oil. This is a very maritime disaster for New Zealand, though they were able to get the most of the remaining oil off the wreck, and many animals died. Like fur seals, and lots of fish, and little blue penguins. It was right on a very pristine coastline full of very special marine animals. So saving our oceans now is a major concern, and we have to do this quickly. We're forming coalitions at every level. We're working with across the country coalitions of environmentalists to try to get a groundswell and to push not only legislation and policy reform, but also push industry to become safer more and quickly, and then to foster development of innovative, safe alternatives to toxic chemicals in our everyday products and toxic ways of obtaining energy from the earth. So when I started, I was talking about Vostok being a high-risk expedition, and it's carried out by very few people who put the rest of us at risk. If the geyser exploded, we would be looking at just catastrophic effects on the oceans. All this would be moving so much faster, and all of us would be looking at probably sea level rise very quickly. And Manhattan is one of the areas that's at great risk, and all along the Atlantic coast. So thank goodness the Russians didn't, do us in, do it for the rest of us. But also, I think the gain there is exploration. That team was driven because they wanted to be the first. What we need to be doing is not making the most money and being the first guys and all that, but doing it the safer way, doing it the way that humankind is not obliterated in the process. And that, I just wanted to say that's pretty much the take home for this, is that we need to do a lot of things more sustainably and safer, and that's what we are working on. Our group and others are launching an ocean toxics project, but we're going to be in a coalition with other environmental projects that are quite large, and I hope you all will stay tuned and become involved with that. Thank you very much for the time.